Hello, I'm Ari Firester, and I designed and built two Earthworm-inspired robots that can maneuver through small holes and difficult terrain. These could be used to search for survivors in piles of rubble, or to inspect damaged machinery, which are both dangerous tasks usually done by people. I chose the Earthworm as my source of inspiration because of how it moves. It uses circular and longitudinal muscles to elongate and contract its body, with claw-like bristles called setae to help grip the earth. This enables the worm to burrow through holes not much larger than its own diameter, an important aspect to incorporate in such a robot. So I built two robots, one that moves using pneumatics and another that moves using servomotors. The pneumatic robot has three compressed air-powered sections, two claw sections and one extension section. The claws, when extended, create a source of friction against which the robot can push or pull itself. And the extension section has three expandable actuators that when all of them are pressurized, the robot extends forward. If only one is, the robot bends. This is how it would turn. The robot is connected to its control panel and its air compressor via this leash of pneumatic tubing. The reason I separated the robot from its controls is because if the robot were to be destroyed, the expensive parts would be spared, making the robot somewhat disposable. The control panel has an Arduino which controls the robot, a transistor panel which opens and closes solenoid valves, and the solenoid valves which distributes the air between the various actuators. For the second robot, I wanted to get more control over the robot's motions and to make it more self-contained. So I did that by putting the electronics inside the robots, and this section contains the robot's brain and the ancillary board, which are responsible for controlling the robot and for dealing with the communications. The extension section works similarly to that of the pneumatic worm, in that it has three actuators. And, however, instead of using pneumatics, I use servomotor controlled hinge mechanisms. The claw section is composed of six elliptical claws rotated out by servomotors, and they can function as the same as those in the pneumatic worm by gripping the earth while it moves. However, if they're rotated like wheels, the robot can motor forward. Additionally, if they're rotated out in sequence, the robot can roll to the side. This robot is designed to be able to connect to another robot head to tail, and it does this using an electromagnet and four servomotor-controlled flippers to engage with the slots in the tail of another robot. And once the robots are connected, the frontmost robot is designated as the leader, and it sends commands to all connected robots, such that the string of robots functions as one large robot capable of more complex motions. The success of these prototypes demonstrates that an Earthworm-inspired robot is a viable model to replace humans in these dangerous tasks, such as search and rescue operations. In future iterations, to be made more effective, could be made more autonomous by adding more sensors, such as heat sensors and more complex cameras.